Okay, 6.2, continue with part 2. There are two other cases. There's side angle side, where you have two sides and an included angle, the angle between them. Or if you have the three sides, the side, 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 where all three sides are known. And both of those are going to be covered in 6.3, so we're not going to talk about them right now. So let's move on to part 3 here, where we talk about bearings. And some of y'all may have talked about bearings in your physics class. But it says that the bearings are used in navigation and surveying, and the directions there are usually given by using bearings. So a bearing is a measure of an acute angle from due north or due south. So we can see here, if you look at the first example, this bearing right here is from the north. Whoops, let me turn my pen on here. From the north going towards the east, 40 degrees. And so you can see they write it like this here at the bottom. North, 40 degrees towards the east. The second one here, you can see they're starting from the north and they're going towards the west. And that angle is 60 degrees. So we say north, 60 degrees west. Same thing on the next one here. This time, though, we can see this starting at the bottom. So it's coming from the south and it's going over to the west. So it's south, that angle, which is 30 degrees to the west. And then the last one here, we see it's starting at the south again. It's going this time towards the east at that angle. So we say it's south, 75 degrees east. Now, every now and then they won't tell you direction, okay? Every now and then you'll run into an angle that just says it has a bearing of 75 degrees. Anytime they do that, it's always starting from the north and going towards the east to get there. So we won't see that with our stuff, but just know that in some of the other classes, maybe physics or I think even my pre-AP pre-cal, they had an angle that said like they had a bearing of 355 degrees. So that would have meant that when they drew their compass rose, starting at the north, going towards the east, they went 355 degrees. Would it definitely have been easier for them to just put that it was north 5 degrees to the west, but they didn't. All right, so just know it could happen, but we usually don't see that, I don't think, in our stuff right now. All right, so let's move on then to example 1. So it says a ship sailing due west at 20 miles per hour records the bearing of an oil rig at north 55.4 degrees west. An hour and a half later, the bearing of the same rig is north 66.8 degrees east. 1. How far is the ship from the oil rig the second time it sees it? And 2. How close did the ship pass to the oil rig? Well, let's draw this, okay? So we've got this ship, and he is going due west. So this is my ship, and he's headed that way, okay? So the first time he sees this oil rig, it's going to be at north 55.4 degrees to the west. So I'm going to draw my little compass rose where my ship is at there. And so from the north, we're going to go to the west 55.4 degrees. So we're going to say this is our oil rig, okay? Call him OR for oil rig. And so this angle right here was 55.4 degrees. Now, it says an hour and a half later, so the ship's still sailing. He's going due west, so he's straight. So an hour and a half later, how far did that ship go? Well, if he's going 20 miles per hour for 1.5 hours, that's 20 times 1.5. So we know he's going 30 miles. Okay, so after he goes 30 miles, the bearing of the same rig is north 66.8 degrees to the east. So if I draw my compass rose right here where my ship is now, he's going from the north to the east 66.8 degrees. So that's that little angle there in the corner, okay? So we've got to figure out how far is the ship from the oil rig the second time. So the distance the second time is right here, because there's a ship the second time, and there's the oil rig. So we're after that. And it says, how close did the ship pass to the oil rig? Well, it's going to pass to the oil rig at the closest point right here, where this is going to intersect that at a 90-degree angle. Now, that doesn't mean it's going to intersect it halfway, okay? It's just going to, that's the line, the straightest line is always your shortest distance. So the straight line from the oil rig to the path of the ship is going to be our shortest distance there. Alright, so I'm going to label my triangle like we did before. I'm just going to let this be A and B and C. So doing that, that means I'm looking for side C right here. And this height here, since I called it a height, let's label it H. So let's look at number 1 there. Number 1 says, how far is the ship from the oil rig? Well, let's see. What do we know? We know that, okay, so we need to figure out what all we know in this triangle that can help us. Well, not looking at that line that I drew down yet, okay? We know that this is not a right triangle because right now with what we've got with the line going down, we don't have enough information and we can't get enough information to use a right triangle anyways. So, but I do know, remember about alternate interior angles? So I know that this little angle right here, oops, I didn't realize I had the same color. Let me change. This angle right here in the bottom left there is 66.8 degrees, which means this angle right here is also 66.8 degrees. And that means this angle right here is 23.2 degrees right here. And we know this is a 90 degree then. Alright, we can do the same thing on the other side here. I know if this little angle right there is 55.4, so is this alternate interior angle. And that leaves this little inside angle here to be 34.6 degrees. And let's see. Ooh, if I know this angle, I know that side opposite, so I need to put that big angle together. So if I add them together, we get 122.2 degrees. So I'm going to use that to help me find side C. So I know sine of 122.2 degrees over, it's the side opposite of it, which is 30, will equal, now I want side C that I labeled side C. What angle's across from it? Angle C, which is 34.6 degrees. So we're going to have sine of 34.6 degrees. So we're going to cross multiply and divide here. So we know that C times sine of 122.2 degrees equals 30 times sine of 34.6 degrees. Divide by that sine of 122.2 degrees. And so in our calculators, we're going to put 30 times sine of 34.6 divided by sine of 122.2. And that should give you approximately 20.132, and this is in miles. So that's telling us that the ship is approximately 20 miles from the oil rig the second time. But 20 miles from the oil rig at the second bearing. Alright, then for part 2 here. Wants to know how close to the ship past to the oil rig. So I'm after that blue line that I drew in there. Alright, so notice it made some right triangles. So even though I really don't like to use information that I had to solve already, I think it's going to help us to do that because I can see that if we just look at this triangle here, I know that this was 20, 20.132. We know that this angle here is 23.2 degrees. And we're after the height. So I know I'm looking for the opposite, and I know the hypotenuse, so I can just plug them in. So we've got sine, because we know opposite hypotenuse, so I have 23.2 degrees equals our opposite over our hypotenuse. And then we're going to multiply by that 20.132. Now, I did catch the other day in the video, Miss Taylor says that you make it a proportion and cross multiply. You can do that too. You get the same answer either way. And so we get that H is going to equal 20.132 times sine of 23.2 degrees. And so let's plug that in our calculators and let's see what we get. Alright, so when I plug this in my calculator, I got 7.931. Now, if you look at the notes that I posted online, mine says 7.879. It's because I used the 20. It was rounded, okay? So, but they're both really close. And so this would be, miles. And so this is telling us that the ship, the closest the ship was to the oil rig, was approximately, and I hate to abbreviate, but I'm going to have to because I'm just out of room, approximately was 7.9 miles. Alright, and there's our two answers that it asked for.